Okay, everybody, this is section 5.1, okay, and this is nth roots and rational exponents. Okay, everybody see that all right? All right, so this section, you definitely want to have out your power sheet that I have attached here, and I really should have saved some space because we really have kind of some guidelines that we have to adhere to. Okay, so the thing is, I need you to keep in mind that we have this, okay, the nth root of a. So I'm going to be changing, so I'm going to put two different categories here. This is when the n value is going to be even. So meaning that it's going to be the square root, fourth root, sixth root, eighth root, you get it. Okay? Now remember that a square root doesn't have, we don't put usually a 2 there, it would just be a square. Okay? So we're talking about the root here on the n, and the a is the number inside the radical. Okay? So this is radical notation. Okay, and then with that, we're also going to be looking at how to go from radical to exponent. Okay, and I'll come back and do that in a second. Okay, so if we have the nth root, then and it's even of a negative number, that would be like trying to take the square root of a negative number. Well, you know right now that you're going to get something on your calculator, you're going to get an imaginary number, so no real roots, okay? Remember, those are going to be imaginary, okay? And if I take the square root of a number 0, well, that's easy. You just get one real root. You get, okay? And if I take the square root of a positive a, I actually get 2 answers, because what do we do when we take the square root of something? We add a plus and a minus. Okay, so this isn't anything new that we've dealt with before. Okay, all right, so wonder if n is odd. So if n is odd, meaning n is the cube root, the 5th root, the 7th root, the 9th root, anything like that, okay? So if I am taking, okay, a negative a, okay, square root, so a cube root of a negative a, I get only one answer. I get a real root. So you can actually take the cube root of a negative answer on your calculator. We also have a cube root of 0. That is also just one real answer. You get a 0. The square root of a positive, or cube root of a positive number, you don't get a plus and minus. If I take the cube root of 27, you actually only get one answer. And here's why. Okay, if I take, for example, the cube root of 27, well, the only answer is 3. Because if I do a negative 3, I get a negative 27. So see how it works a little bit different. Okay, so that's the part that really kind of blows people's minds after a while, is getting 2 answers or getting one answer. Okay, so let's do a few. So I'm going to make a very small example here. I'm going to have, okay, a couple small examples here with these first couple concepts. So if I take, let's do the square root of 16. Okay, the square root of 16, you're like, well, that's easy, Mrs. Bassett, that is 4. Right, but remember, that can be a plus and minus 4 because 4 times 4 is 16, but also negative 4 times negative 4 is also 16. Okay, how about the cube root of negative 81? Now, cube root, you can actually find that on your calculator in the math button. Just like when we frac things up, you can actually find that the cube root in there as well. Well, that actually is, do we even have that? I think it goofed up. No, that would be 27. How about, better do a negative 27. Nah, I need something better. How about negative 125? There, that's better. Negative 125. Well, that's negative 5 because negative 5 times negative 5 times negative 5 is negative 125. Sorry about that. Okay. So the first couple ones that we're working on, we're actually going to do with just the power table and not use our calculators because we can actually find this on that fancy power table. So if you're not sure what I mean by the power table, I will find the power table and show you what I mean by that, because the power table is a wonderful resource. Okay, so what I mean by that on the power table, so this is the power table, and the first blank is all square roots and then cube roots. And so if I'm taking the cube root of something, I can look over here. Oh, the cube root of 125 is 5. So you can actually find the answers. So you're going to have to use your power table to start out with. Okay, the second part is that line that I drew up here. So this is in radical form. This can also be written as an exponent, and it would be this. So notice where the n goes. So any radical can be written as an exponent, a rational exponent, which is why our title says rational exponent. Okay, so the second part of the section is writing, going from radical to exponent and back. Okay, and exponent to radical. Okay, so here we go. The cube root of x to the 5th power. How do I write that as an exponent? Well, that's easy. Okay, this goes on top, but the radical part always goes on the bottom. So this would be x to the 5/3. All right, how would I write x to the 7/2? Well, this one is, now you don't have to write the 2. We assume if you leave it blank, it means it's a 2. Okay? Questions on that piece? Okay, the second part I want to deal with is getting rid or using no calculator and then using the calculator. Okay, so this would be evaluating using a calculator. Okay, so in this part, so without a calc, okay, the cube root of 8 squared. Okay, so remember that you can think about it, the cube root of 8 squared. You can also think about it as 8 to the 2/3 power, but to me, it's just easier if you go, okay, so the first thing we're to do is, does 8 have a cube root? And the best way is, we're not going to memorize this table. You will learn these, and these will commit to memory just because we're going to use it so much. So let's look at cubed, and does 8 show up? Oh, it does. That's right there. So the cube root of 8 is 2. Well, that's easy. So the cube root of 8 is actually 2. And 2 squared, well, I can do that. That's easy. I can do that in my head. That's 4. Done. I didn't even have to use a calculator. Awesome. So there will be parts on the tasks that I want you to not use a calculator for, okay? Now we're without a calculator, okay? 8 to the negative 4/3. Okay, so right away, we know that a negative exponent sends this to the basement. So 8 to the 4/3. Okay, the second part, what I would do if I'm doing this without a calculator, is I need to rewrite this so that I at least can see what so this would be the cube root of 8 to the 4th power. Okay, so we just did that, didn't we? We just did the cube root of 8. So the cube root of 8 is actually 2, isn't it? And 2 to the 4th power, well, that's easy. That's 16. So 1/16. See, I didn't even need a calculator. You totally knew that. Now, I know I skipped a spot right here, okay? But I'm going to come back to that in just a second. Okay, here's another one. How about this one without a calculator? Negative 125 to the negative 2/3 power. So a double negative. Okay. So first of all, the first thing I'm going to do is I'm going to move this to the basement. Now, it's still a negative 125, friends. Okay. It's still a negative number. All right. Well, and now I'm going to rewrite it. That's the cube root of a negative 125 squared. Well, friends, we did negative 125 up there. And remember, it's cubed. So the cube root of negative 125, well, that's a negative 5. And negative 5 squared, well, that's a positive 25. Done. Okay, I saved this box because I want to show you how to kind of do it on your calculator. Okay, so here's the cube root of 38. And if I ask for it, of course, well, we'll have to do this. So here's what would happen. I'll tell you. So you would go to math, because it looks like I need batteries, doesn't it? You would go to math, and there's a cube button. So you cube and then 38, which the answer I'm going to tell you, let's see, cube root of 38. Cube root of 38 is probably between 3 and 4. So my guess is going to be 3.2 something, something, something. So you'll have to check back with me on that one. Okay, I'm just estimating it in my head. You would actually get a decimal answer. And the whole part of this is to be able to solve. So here's our last two. These are actually solving. So I'm going to leave this all as one so you understand this is the same concept down here. So here we go. 2x to the 6th equals 1458. Okay, so my goal here is to solve for the x, okay? Get the x all by itself. So if I were to onion this out, the first thing I'm going to do is get rid of this 2. Okay, so what is 1458 divided by 2? Well, that's a really good question. I'm going to have to get out my plain Jane calculator. Well, that doesn't work either. Wow, I'm going to have to really old school this. 1458 divided by 2. That'd be 7, goes in there twice with 1 left over. 9. How about 729? Okay, 729. Now, what is the opposite of taking something to the 6th power? Taking the 6th root of each side. So let's use I don't want to use my calculator because I don't have one. And I'm going to look up the 6th root. Oh, look at it. It's right there, 729. So the 6th root of 729 is 3. Yay. But it's a even number, even root. So I want to go back up here. Oh, I need to make sure I put a plus and a minus with that. Yay. All right. Good deal. All right. It is okay to, we're going to use a decimal here, best we can. So again, I want to solve for x, but in order to do that, look at, I need to take care of that cube first because it's held. This is not the same as x cubed, 4 cubed. So I need to take the cube root right away. This should look familiar. We kind of did this on FIM last year. So x plus 4 is equal to, now the cube root of 12. The cube root of 12 is slightly like 2.45, I think. I'm not really sure. Again, I don't have a calculator here. Is it plus and minus? Well, no, because it's a cube root. So I'm going to leave it like that. And then I'm going to go and I'm going to subtract 4. Okay. So what is that? 1, let's see, that'd be a 5, would get me up 55, would get me up to 3, negative 1.55. You'll have to correct me if I'm wrong on that one. Okay, so this is a really important section. This is really starting us off in this chapter is a really important section. So we're going to practice working these different concepts together. Okay, thanks.